Well then, welcome everyone. Polkadot is rewriting the history of smart contracts, and we are bringing the most advanced, ultimate, state-of-the-art smart contracts technology to your hands. Some weeks ago, Vitalik floated the idea of replacing EVM with a RISC-V architecture as the only way forward for scaling. But let's imagine that future is not 5 years from now. It's not 1 year from now. It's already here, and it's on Polkadot. So yes, Polkadot already supports RISC-V, and yes, you can build on it today. And for those that are hearing for the first time, think of Polkadot as a cloud that is doing to Web3 what AWS is doing to Web2. And its architecture comprises of 3 main components: the services that you can build on, the systems, applications, and the interoperability layer. At the moment, you can build 2 types of services: smart contracts in our Polkadot Hub, an Ethereum-compatible smart contracts platform that you can leverage all the EVM tooling that you have at the moment: Hordet, OpenZeppelin, Foundry, and all the wallets. And you can also build rollups, the equivalent of L2s on Ethereum. The systems programs allow for governance, the treasury, and you can directly access them through your applications, through your smart contracts, and through the rollups. And finally, the interoperability. XCM protocol allows, for example, for you to communicate through your smart contract with another rollup. For the rest of this presentation, I want to show you how all of this works behind the hood, how you can go to market and scale up your business, why choosing Polkadot, and what you can do for the rest of the week, and what you can start now. So let's visualize you just developed your Solidity smart contract. What we're going to do is we're going to grab that code and we're going to compile it using Sol-C, the standard Ethereum Solidity compiler frontend that generates a YUL, Solidity's low-level intermediate representation. Next, we run that YUL through our state-of-the-art compiler, which translates it into LLVM, the same intermediate language that is used in most modern software languages like Rust and C++. From there, we optimize and compile the code to RISC-V machine code, a clean, open hardware instruction set. And finally, we link the result into a Polkadot-compatible metadata blob, a format that can be executed and deployed on-chain. The entire compilation and optimization pipeline happens off-chain, so in your local setup, for example. And the final artifact is fast, portable, and ready to run within the Polkadot runtime. So why not EVM contracts? Well, it's the industry standard. And yes, it's true that EVM is mostly widely used and adopted within Web3 today. Most layer 1s and L2s support EVM. But there's a catch. It is painfully slow. Any smart contract that does real work, like verifying cryptography or some mathematical complex logic, needs precompiles, for example, so that the gas use is low. That's like saying, here's the computer, but for anything else, you need to plug in some adapter. And the EVM is also not a general purpose virtual machine. and it has limited usefulness. It's not used outside of Web3, for example. So EVM is constrained. It's domain-specific language like Solidity or Viper, since blockchains that adopt EVM are basically resource-metered virtual machines and need these specific languages to run. And another question is, why not WASM contracts? They have widely language adoption, but they take orders of magnitude longer to compile than EVM contracts to execute. So there's already benchmarking studies, for example, this one that compares Polka VM recompiler, Polka VM interpreter, Solana RBPF, and WASM. All the last three are state-of-the-art technologies. And we can see that the compilation times is significant in Polka VM compiler, but the execution time is much slower than the other technologies. So, and Polka VM recompiler is super optimized, and we can also use Polka VM interpreter for other use cases. For example, the first to execute the same smart contract again and again, and the interpreter for other kinds of use cases. So in the end, what we want to achieve is 30 seconds finality, which in comparison to Ethereum is 7 days. Sub-second block times, Ethereum-compatible tooling, where you can port all your existing code into our platform. Reliability and low latency. True integration and native interoperability through XCM, and direct access to our system applications. The current tools to build on Polkadot Hub that you have available for this hackathon, for example, is Hardhat. So we have developed a plugin, Plug and Play, and Remix. And many more are to come at the end of the year. So what you can do to go to market and to scale up your application? Polkadot offers a very clear path to scaling, which is you can build your own rollup that supports high volume and low fees. We already secure 40 million plus transactions per month, and these are consistently with low fees. Polkadot architecture was actually first built for L2s and rollups. So it's super optimized for this use case. And it's built to help you scale. In AWS, you have a pay-as-you-go model. In Polkadot, you have a pay-as-you-go model. And we have developed state-of-the-art methodologies or technologies like elastic scaling. So why Polkadot? And the answer takes into account many factors. One of them is bandwidth. So at the moment, we provide the most data availability by a large margin compared to other solutions. We are the most resilient. We, in fact, have the greatest Nakamoto coefficient. And why decentralization matters, you may ask. Well, it's way different to build $1 million business or a multi-billion-dollar business. And we believe that trillion-dollar and multi-billion-dollar businesses can be built on Polkadot safely and reliably. And we are here to support that path. We are the most energy efficient and the fastest by TPS, achieving hundreds of thousands TPS in live networks. We have a wide ecosystem of entrepreneurs and environments where you can go from a student to a professional. You can go from an hackathon idea to a business. And the last question I want you to think is what to do now, what to do for the rest of the week. We have 3 tracks for this hackathon. The first one is porting existing smart contracts on open source projects or your own projects into Polkadot Hub, our Ethereum compatible platform, and try to understand how it performs in comparison with other EVM platforms or other technologies of your choice. Just make it very explicit what the differences are, and is it worse? Is it better? And what's the real benchmarks on all of this? You can create your brand new Solidity smart contract, build a business model around it, pitch it, make it clear, and try to take advantage of what I've just, the advantages that Polkadot Hub offers at the moment. And the price pool for this one is split into 3 different prices, approximately 800 for each. And the last is to enhance the developer experience, creating libraries, tools, plugins of your choice, with special consideration with the documentation and everything else around it. We are in the booth, and we have a team that is here to help you and has access to mentorship opportunities, to grants, and to help you grow the idea into a business, or if you already have a business in mind and you want to integrate Polkadot, we are here to help you do that. So you can find support with these 3 lovely individuals, me and some other folks that are very easily recognizable through their t-shirts and what they're wearing. So the next step is a demo, a quick demo that I want to show you. Okay, let's try. Yes. Okay. So I'll first create an npm repo, and I will install some dependencies. Bear with us. We are releasing a new version today, which is way more simple. You can use already the latest version of Hard Hat, and it follows the documentation that you can find in npm.js and all our available documentation. This is just one example of how you can build with RISC-V at the moment. You can also just go to contracts.remix.io and build from there. Okay, this one. Okay. So now I will initialize a project with npx hardhat polkadot init. And lastly, I will compile. And as you can see, it generates Polka VM compatible artifacts that you can see up there, the artifacts PVM and the cache PVM, and the rest you can find in our documentation and or with us outside. So you can configure, for example, a live network. At the moment, it's called Paseo. It's the Polkadot testnet. Or you can spin up a local node that uses just a substrate node. At the moment, with this version, you have to compile the binaries on your local machine and then provide a path where it says ETH RPC. But in the new version, all of this will be hidden away with Docker containers. So this is the end of my presentation. I wish you great luck, and we're here to support during the rest of the week. Thank you. Right. Let me. So ideally, you want to create a smart contract and deploy it, for example, on Polygon, on Ethereum testnet, and execute it and try to track how much time it takes and how much what's the cost of executing this particular logic. You can do the same in Paseo and compare. Now, you may find that, for example, deploying to Paseo takes way longer than deploying to Sepolia, the exact same logic. But that could be, for example, RPC still not yet optimized. So we will take into consideration a lot of the effort and the idea path that you have. But for the good or for the bad, just try to make the sense of trying to compare both platforms. Ideally, you want to build something that's heavily it has some heavy computation. You can create like a for loop and see where it goes. Also, it would be interesting to see if the gas limitation for deploying a smart contract differs. So if you can create a really big, very large in size metadata blob and deploy in both platforms. Yes.
I remember with Western there was some limit on the contract size. Does Paseo has the same limit or not?
It should have the same limit. Though we through hard hats we did patch a function that was limiting in hard hat, so it would throw this error. So if you deploy through there, maybe this particular error is not there anymore. Okay. Yeah, go ahead. Okay. Well, so from where I understand, you want to compare the size of the bytecode that's generated with our compiler and the bytecode that's generated with Sol-C, for example. Okay, so you may so basically the same logic could have different bytecode sizes. Well, it's a very good. It's exactly that kind of exercise that we want participants to do for the first track, and see where it goes. I think that's a nice idea to explore. Yes.
Traditional finance uses Haskell and OCaml languages for their lazy interpretation and some millisecond reaction times. Do you have any kind of plan to port some of the existing functionalities into those languages?
Yes, we do. And yeah, so support basically more than Solidity and more than Rust. Also, it's worth mentioning that you can also build Rust smart contracts in Polkadot Hub. In this presentation, I only focus on Solidity because that's really what other platforms offer at the moment. But we do have intentions of supporting multiple languages, and I encourage every hackathon participant to actually just try to build their own interpreter. Any more questions? Great, thank you very much for listening. Have a great week.